Alright guys, I'm here to talk about how we can describe and classify real numbers. We're here to talk about real numbers. We're not talking about imaginary numbers or fake numbers. So everything on this last test was all about real numbers. Real numbers consist of two separate subgroups. We have rational numbers and irrational numbers. Both groups combine to make the real number system. Now how do we know what is what? Rational numbers are numbers that we can make into fractions. If you can make it into a fraction, then it is rational. Irrational numbers are numbers that you cannot make into fractions. Numbers like non-repeating, non-terminating decimals cannot be made into fractions and thus are irrational, and non-perfect squares and perfect cubes, non-perfect cubes, are irrational numbers. You can't make them into fractions. They're still real. I always use the excuse in class, if you know a person that seems a little irrational, they're a little crazy, those individuals might be a little weird, but they're still real people. So they're real numbers. These are real numbers. Fractions, or rational numbers that can be made into fractions, consist of many subgroups. Integers, like whole numbers and their opposites, all can be made into fractions, so they're rational. Fractions obviously are going to be fractions. Perfect squares can be turned into fractions, and terminating decimals and repeating decimals can be made into fractions. So let's do a couple of examples and try to work through them. I like to work from the bottom up, labeling as many descriptors as possible. For example, let's say I have the number 0.4 repeating. This number is a decimal, so we're kind of move over to the area where we have decimals, but this is a repeating decimal, so I can label it repeating. Since it's repeating, I can make it into a fraction, and thus it is rational. So I can label it as rational as well. And since it's rational, it is a real number. This number as a fraction is 4/9, hence why it's rational. Let's do another example. Let's do the square root of 61. This number has a square root symbol, so there's a square root symbol, there's a square root, but this is not a perfect square. Square root of 64 is perfect, but square root of 61 is not, so it would be considered irrational. And from there, we can still see that irrational numbers are real. And that's all we'd have to label it as. Let's do another example. Let's just take the number -3. -3 is an integer because it's the opposite of +3. So I can label it as integer. I can make this into a fraction, -3/1, so it is rational. And all rational numbers are real. See how I kind of just move up my tree diagram here. The number 5.7 is a decimal, so I'm going over to this idea between decimals here. And this is what we call a terminating decimal. It just ends after the 7 here. So I can just put terminal here, terminating. Terminating decimals can be turned into fractions. I can make this 5 7/10, since the 7 is in the 10th position. Since I can turn this into a fraction, I can say this is rational. And rational numbers are, again, real numbers. Let's do two more examples. Let's try 0.232332333 and so on. Since this number is a decimal, we're looking in between these two groups here, but it doesn't repeat. It does have a pattern, but it's not a repeating pattern. And it doesn't terminate, it continues on forever. This would be classified as non-repeating, non-terminating, which is considered an irrational number. No matter how hard I try, I cannot make that into a fraction. And then irrational numbers are real numbers. They exist. Last example, square root of 81. This is a square root, so I'm looking for squares here, and it's a perfect square. This is the same thing as the number 9. So I can say that this is a perfect square. I can make this into a fraction by propping it up with a stick and making 9 over 1. So this is going to be rational since I can make it into a fraction. And all rational numbers are real. Hope these examples helped.